ஹாய் வியூவர்ஸ், எல்லாருக்கும் வணக்கம். வெல்கம் டு செவிவழி கல்வி சேனல். நாம இன்னைக்கு டிஜிட்டல் லாஜிக் டிசைன் அப்படிங்கிற சப்ஜெக்ட்ல டிசைன் அண்ட் அனாலிசிஸ் ஆஃப் கிளாக்டு சீக்வென்ஷியல் சர்க்கியூட் அப்படிங்கிற கான்செப்ட் பத்தி பார்க்க போறோம். ஸோ இது வந்து டிஜிட்டல் சர்க்கியூட்ஸ்ல ரொம்ப இம்பார்ட்டண்ட்டான கான்செப்ட். ஸோ நார்மலா டிஜிட்டல் சர்க்கியூட்ஸ்ல பாத்தீங்க அப்படின்னா காம்பினேஷனல் சர்க்கியூட் அண்ட் சீக்வென்ஷியல் சர்க்கியூட்ஸ்னு ரெண்டு கேட்டகரி இருக்கு. ஸோ அந்த ரெண்டு கேட்டகரியில காம்பினேஷனல் சர்க்கியூட்ஸ் வந்து ஆல்ரெடி நம்ம பார்த்தாச்சு. சீக்வென்ஷியல் சர்க்கியூட்ஸ்ல சின்க்ரோனஸ் சீக்வென்ஷியல் சர்க்கியூட், அசின்க்ரோனஸ் சீக்வென்ஷியல் சர்க்கியூட்ஸ்னு ரெண்டு கேட்டகரி இருக்கு. ஸோ அதுல தான் நாம இப்போ வந்து கான்செப்ட் பார்க்க போறோம். ஸோ அதுல சின்க்ரோனஸ் சீக்வென்ஷியல் சர்க்கியூட் ஆர் சின்க்ரோனஸ் clocked sequential network பத்தி தான் நம்ம இப்போ இன்டெப்தா பார்க்குறோம். So in this clocked sequential networks are represented by two models. One is called as Murray model and another is called as Mealy model. So otherwise Mealy circuit or Murray circuit also we can say. So in synchronous or clocked sequential circuit, clocked flip-flop are used as a memory element. So normally we know very well that flip-flop can be used to store only one bit of data at a time. So in clocked sequential circuit, more number of flip-flops can be used to store multiple number of binary datas to store at a time, and which change their individual states in synchronism manner with the periodic clock signal. So always we are preferring periodic clock signal. That means the duty cycle both on time and off time of the clock signal should be same for all the clock pulse, and both flip-flops having the same synchronized clock signal. So that is the main concept in synchronism concept. And therefore the change in any states of flip-flops and change in state of the entire circuit occurs at the transition of the clock signal. So transition is nothing but from state changes from one state to another states. That means, for example, if you consider 0 0 0 1 1 0 1 1, there are four states in a particular state diagram. So from 0 0 to 0 1 changes is there. That means the state is now changed from 0 0 to 0 1. That is called as the transition of states. Similarly, from 0 1 to 1 0 transition is occurred. That is another state transition. So similarly, it depends on the number of variables present in the given circuit, and as per the example, number of states present in the circuit and how many number of transition can be taken place can be determined, and based on that we can able to draw the state diagram or state table, etc. So now let us see the difference between the Murray model and Mealy model. So this is a structure or block diagram for Murray model. So this is input variables which is given to the next state decoder. So after the next state decoder, it will produce the excitation variables. So that is now applied to the memory elements for storing purpose, and it will produce the output. Now this output is again given to the feedback, to the next state feedback decoder. That is called as the state variables. So the output depends only on the present state of the flip-flop. So that kind of structure of the diagram is called as the Murray model or Murray circuit. So it appears only after the clock pulse is applied. That means it varies in synchronism with the clock input. So this is the Murray model structure and the concept behind the Murray circuit. And let us see the Mealy model. The same structure is present in this Mealy model as it is like Murray. But one important concept in output decoder additionally we are adding here. So the next state decoder gets the output, gets the input variables, and it will produce the excitation variable, and it is applied to memory element. That output of memory element is now applied to the output decoder, and it will produce the final output variables. Now this memory element output is sent to the feedback input to next state decoder as a state variable. At the same time, the inputs again applied to output decoder also. So that means the output depends only both present state and on the flip-flop and input. That means the present state of the flip-flop and present input, which is given to the circuit. So based on this concept, the Moole circuit can be designed. So this is the basic structure for Moore circuit and Mealy circuit. Now let us see the comparison between Moore model and Mealy model. So in Moore model, its output is a function of present state only. That means what is the present input you are going to give. It is not bother about what is the present state, that only consider, and based on this present state the output will be produced. That is called as a Murray model. And Mealy model is a one kind of circuit. Its output is a function of present state as well as the present input. So input changes does not affect the output in Murray model, but when we go for Mealy model, input changes may affect the output of the circuit. So Moore model requires more number of states for implementing the same function, but Mealy model requires a less number of states for implementing the same function. So this is the comparison between Mealy model and Moore model. Now let us see the state diagram. So state diagram is nothing but it is a pictorial representation of a behavior of the sequential circuit. So what is the nature of the sequential circuit? It will accept the input and it will produce the output, depends on the applied clock pulse, and that clock input signal should be in the synchronous manner, and it depends on this state transition, and also what is the present input given to the particular state. Everything should be represented in the form of diagram, so which is called as a pictorial representation. So the behavior of the entire sequential circuit is represented in the form of pictorial form, which is called as a state diagram. So this is one small example for state diagram for Mealy model and also Murray model. So what is the difference between these two diagrams? So both examples consist of four states, which is denoted as a variable A, B, C, D. And here we have to differentiate with very important symbols and concepts. So here always the state variable should be represented within the circle itself for both Mealy model circuit and also Murray model circuit. So here we have four state, which is A denoted as a variable. It is a starting state. So A is first state, and after that B state, which is represented within the circle. And again C is another variable or another state which represent within the circle, and D variable also represent within the circle. So now the circle which consists of any particular variable which is called as a state. So now the state transition is taken place, can be done through the help of arrow. That means from the A state to A state transition is taken place. That means இந்த இடத்துல இங்க என்ன நடக்குதுன்னா A stateல இருந்து A stateக்கே வந்து transition நடந்திருக்கு அப்படின்னு நாம இந்த இடத்துல சொல்றோம். That means the transition is occurred from A state to A state. It is one case. At the time input is 0 and output is 0. So we have to remember one important thing for both the Mealy model and the Moore model. The arrow indication is mainly used to refer or indicate the transition of state from one state to another state. And also we have to separate the input and output with the help of the symbol slash in Mealy model circuit. So the first value is represent the input, and the second value after this backslash represent the output. So this is a main important thing we have to remember when you draw the state diagram for Mealy model. The same diagram can be taken here also in Moore circuit, but within this state, the in numerator we have to give the state variable, and in denominator we have to give the output of this particular transition. state transition. That means uh, both numerator and denominator should be included within the circle itself. In Murray model circuit, A, R, B, C, D are represents the state of this particular logic diagram, and in numerator we have to represent the state variable, and in denominator the output of the particular state transition is mentioned. And in arrow indication we have to only put input value. So for this case, from A to C transition, the corresponding input is denoted as 1, and the output for this transition is 0. Similarly, C to C transition is taken place and the input value is 1, output also 1. So C to D transition, input value is 0, output also 0. So these are separated or segregated with the help of this backslash. And here the D state is again transition or move to the D state when the input is equal to 1 and output is equal to 0. Similarly, the Mealy model and Murray model circuits can be explained like this. So in this case, Murray circuit, only the input should be present in this arrow indication. Within the circle, the state variable and output values are present. So that is the main difference between the Mealy model and Murray model state diagram. So after that we go for the state table. So state table is nothing but just to describe the behavior of the sequential circuit for understanding purpose. That is the entire transition or conversion of the pictorial representation of state diagram into table or truth table, which is called as the state synthesis table or state table. That means in tabular form, we are going to represent our state diagram, transition, variables, input, output within this table, which is called as the state transition table, state synthesis table or state table. So next, if you want to reduce the state table, if it is possible to reduce the state table, we can able to reduce for the particular number of states when the same next state values and output values are same. For this case, we can able to reduce the states. That is called as a reduced state table. And transition table is nothing but we are saying the state assignment. That means what are the different variables and input output values are present in this state table. Everything is present in transition table, but instead of the particular variable, here we have to assign the particular state values. For example, in this case, A state, B state, C state and D states are available. So for A, we just represent 0, 0 is the value. For B state, 0, 1 is the value. For C state, 1, 0 is the value. And for D state, 1, 1 is the value. So the A, B, C, D, the four sequence of present state binary values are now replaced by variable, and this representation is called as the transition table. So here also we just change the variable by the 2-bit values. For next state, when the x equal to 0 and x equal to 1, at the same time for output x equal to 0 and x equal to 1, what is the output value. For the state table, everything is present here. So this is the small information about state transition table. So already we have seen the state reduction technique. That means if there is a possibility to reduce the number of states in the given state tables and state transition table, that means the both state values are having the same next state value and output value, that can be represented as a single variable and a single state. So finally it will reduce number of states present in the final diagram. So this is the basic concept behind design and analysis of clocked synchronous sequential circuit. I hope everyone understands this concept clearly. So in next video, we will see the problems for solving Murray model and Mealy model examples for synchronous sequential circuit. Thank you all. I hope everyone understand this concept clearly. So kindly view this video and subscribe my channel. If you have any doubt, you can ask me at any time. Thank you.